Okay, so in this video, we're going to talk about moles and Avogadro's number. All right. Now, first, we need to kind of go back and just revisit the concept of atomic weight. Okay. Now, remember, the atomic weight is just it's the average mass of an element's atoms. So remember, per element, you have multiple different types of isotopes, and so when we average the isotopes and their masses with the percent abundance, we get the atomic weight. Okay. And so when we look at a periodic table, like what you see here. So for example, if you look at lithium, all right, so lithium's atomic weight is 6.941, all right. Beryllium's atomic weight is 9.012, all right. And then we could look at scandium's atomic weight. It's 44.956. So these are all the atomic weight of your elements, and this is where you can find them on the periodic table. Now, molecular weight is the average mass of a substance molecules, all right? And so here we're still talking about mass. Now, a substance molecular weight, or formula weight, if it's an ionic compound, all right, is the sum of the atomic weights of all the atoms in the molecule or formula unit. All right, so what do I mean by this? Okay, so for example, let's talk about the compound C2H4, all right? And I want to figure out what's the molecular weight of this compound here, all right? This compound's called ethylene. So what you'll do is that you want to look at the atomic weights for each of the elements that make up this compound. So you want to look up the atomic weight of carbon, all right, and you want to look up the atomic weight of hydrogen. Okay, so let's pull a periodic table and see what we're talking about. Okay, so here's our periodic table, all right, and so now what we're going to do, we're going to look and see the atomic weight for carbon. So if we look here, we see that the atomic weight of carbon is 12.011. Okay, and so let's go back to the C2H4. So, or C2H4. And so we have the carbon atom weight, atomic weight is 12.011. All right, and this is measured in AMU, atomic mass unit. So this is the unit, all right, for that atom, or for these atoms. All right. Now, if you notice that there are two carbons, all right, in this molecule. All right, so we want to make sure we want to multiply the mass of the atomic weight of carbon by 2. And so that's what I'm going to do here. So I'm going to multiply this number by 2. All right, so when we do that, we get 24.022 AMU. All right, now we want to look at hydrogen. So let's look at hydrogen. So hydrogen's here. The atomic weight of hydrogen is 1.008. All right, so hydrogen is 1.008 AMU. All right, and if you notice, we have 4 hydrogens. All right, so I'm going to multiply this number by 4. Okay, and so when I do that, so the answer here is 4.032 AMU. All right, so now we know what's the total mass, or the total atomic weight for carbon, the total atomic weight for hydrogen. And so what we're going to do, we're just going to simply add them up. And so when we add them up, we get our answer to be the atomic weight of C2H4, or the molecular weight, not the atomic weight's for atoms, but the molecular weight, so we're looking at the weight of the whole molecule, is 28.054 AMU. All right, so that's the molecular weight for this particular compound here. All right, let's do another one. So that way we could go practice. So molecular weights for molecules. Molecules are covalent compounds, right? We also what we call formula weight. All right, and formula weights are really just for those of ionic compounds. And so let's say if we're trying to figure out what's the formula weight of calcium carbonate, all right, which is the main ingredient in Tums. Tums is really just chalk. Chalk is calcium carbonate. All right, and so let's go ahead and look at the main ingredient. Let's figure out the formula weight All right, so we're going to figure out the formula weight for this particular compound. So we're going to look up the atomic weights for each compound. We're going to look, for each element. So we're going to look up the atomic weight for calcium, the atomic weight for carbon, and the atomic weight for oxygen. Now, there's 3 oxygens, so we got to keep that in mind. So for calcium, we have this right here, and we see that calcium's atomic weight is 40.078. All right, so it's 40.078. AMU. All right, so now let's look up for the one for carbon. And so the one for carbon is here, and we see that the atomic weight for carbon is 12.01. All right, and so carbon is 12.011 AMU. All right, and then let's also look up the one for oxygen. And so what we see here for oxygen is 15.999. All right, so that's the atomic weight for oxygen. Okay, so 15.999 AMU, but we gotta multiply this number by 3 because there are 3 oxygens. All right, so when we multiply this number by 3, what we get is 47.997 AMU. Okay, and what we're going to do now, we're going to add up these 3 numbers. All right, add up your calcium atomic weight with the carbon atomic weight with the oxygen's atomic weight to get our formula weight for calcium carbonate. Okay, so we get 47.997 plus 12.011 plus 40.078, and what we get is that the molecular or the formula weight for this compound is CaCO3. The formula weight is 100.086 AMU. So that's the formula weight for calcium carbonate. So this is how you calculate the molecular weight or the formula weight for any type of compound. Now, I want to kind of talk about a really interesting relationship that Amadeus Avogadro, who was an Italian scientist, discovered when it comes to the relationship between the mass and the number of atoms or molecules, so number of these particles. So recall that carbon, right? Carbon has a atomic weight of 12.011 AMU. Okay. Now it turns out, atomic mass unit, it's a very, very, small mass unit. All right, so it's a mass unit at the atomic scale. So here, when we talk about 12.011 AMU, we're really talking about the mass of a single atom. Okay. Now, what a very interesting relationship that we find in nature is that if you saw to happen to have, for carbon specifically, right? So we're talking about the carbon atom. If you so happen to have 12.001 grams of carbon, all right, we have a very specific amount of molecules or of carbon atoms. Okay. Now, get this. So that's what for carbon. And remember, when we talked about hydrogen, right, we said that, not hydrogen, oxygen, all right, its atomic weight is a 15.999 AMU, okay? And so if we were to get 15.999 grams of oxygen, all right, we will have the same number of atoms between the two. All right, even though they're different weights or different mass, but we have exactly the same number of atoms. All right, same thing with if we have hydrogen. We saw that hydrogen's atomic mass or atomic weight is 1.008 AMU, right? And then if you were to have 1.008 grams, all right, so we're talking about real grams, well, then you will also have the same amount of atoms between the three. Now the question is, how many atoms are we talking about? What is that number that if you sort of happen to have that many grams, or the grams with the same magnitude as what we could find in the periodic table, how many atoms do we have? Well, we have 6.022 times 10 to the 23rd of these particles. All right. This number here is called Avogadro's number. All right. Which, to help celebrate the Italian guy who kind of first recognized this interesting relationship. Okay. And we'll dive in more into Avogadro's number a little bit more. But it just turns out that anytime when you have just about the mass, which is the same number in magnitude as what we find on the periodic table, the atomic weight, all right, we will have 6.022 times 10 to the 23rd of that particular substance. Okay. Now this number, we simply call it a mole. Okay. And so when we say we have 1 mole of a substance, we're saying that we have 6.022 times 10 to the 23rd of that particular substance. Okay. So let's say if we say that, all right, I have 1 mole of carbon, okay, of carbon atoms, then I have 6.022 times 10 to the 23rd carbon atoms. Okay. If I say that I have 1 mole of oxygen, all right, atoms, then I have 6.022 times 10 to the 23rd oxygen atoms. Okay. Now, mole, if you notice, right, a mole is a counting unit. Okay. And we have several counting units in the English language. Okay. So what do you mean by counting units? It's basically a number that or a word that represents a specific number. So like, for example, if I say, hey, I got a pair of shoes, right? Well, you could automatically think when I say pair, we're talking about 2. Okay. If I have a dozen cars, I don't. But if I have a dozen cars, okay, then we know that word dozen simply means 12. Okay. If we say, look at the trio, right? And we know the word trio means 3. 3 of. Okay. And so anytime you see the word mole, it represents 1 number, and that number specifically, all right, is 6.022 times 10 to the 23rd of whatever we're talking about. Okay. So, a mole of cats. Actually, that's kind of scary. But yes, some people want a mole of money, I mean, that will make you, a millionaire, whatever. But the whole idea is a mole represents 1 number. That number specifically is 6.02 times 10 to the 23. Now, don't confuse a mole with mass. Okay, so like, for example, a mole of carbon, right, has the mass, like we mentioned, 12.011 grams. Okay, a mole of oxygen has the mass of 15.999 grams. A mole of hydrogen has the mass of 1.008 grams. So obviously when we're looking at these 3, I mean, we could say, okay, if I have a mole of something, which one will have, which one have a greater mass, lower mass, whatever the case is. And you just have to look at the periodic table and look at the atomic weights. All right. And the atomic weights will give you the mass, which will help you figure out, how much does 1 mole of a substance will weigh. Okay. And so do not get that confused. Remember, mole is just a counting number, right? And grams measures mass, how heavy something may be, right? Much like if you think about this, a dozen houses do not weigh the same or do not have the same mass as a dozen cats. You have the same number, a dozen you have 12, 12, but the masses are very different, right? A dozen houses will definitely be a lot more massive than a dozen cats. All right, so same thing here. Because I have 1 mole of carbon or oxygen or hydrogen, doesn't mean the masses are the same. No, it just simply means I have the same amount. All right, and so these numbers, how many atoms I have, are exactly the same, and it's 6.022 times 10 to the 23rd. All right, so do not get confused with that, right? And so, like, for example, we could always ask this question, which one is more massive, right? If we're talking about which one has more mass, and if I state 1 mole of calcium or 1 mole of xenon, okay? So what you want to do is just look at the periodic table, and when you look at the periodic table, you remember that 1 mole represents on the periodic table the mass of that atomic weight that we see here. And so if we pull up a periodic table, so let's go ahead and pull one up, and then let's investigate this. And so we see calcium. 1 mole of calcium will weigh 40.078 grams. All right, while 1 mole of xenon, we go here, has the mass of 131.294 grams. Okay, so we have the same amount of elements there, but the mass is different. Okay, all right, so just kind of keep that in mind. All right, now this relationship, all right, between the mole and the mass is what we call the molar mass. All right, which basically illustrates the mass of 1 mole of a particular substance, whatever that substance may be. Okay, and so if I were to ask you, all right, hey, what is the molar mass of carbon, right? Well, what we do know is that for that carbon, there's 12.011 grams for every 1 mole of carbon. Okay, and the way that we typically write this is 12.011 grams per 1 mole of carbon. All right, so the units for molar mass is grams per 1 mole, okay, or grams per mole. All right, so same thing if I ask you, okay, what is the molar mass of oxygen? All right, and we know that 15.999 grams of oxygen, that equals to 1 mole of oxygen, or 6.022 times 10 to 23rd of oxygen. Then we say that the molar mass is 15.999 grams per 1 mole of oxygen. Okay, your units, once again, want to highlight this, is grams per 1 mole. Okay, same thing for hydrogen. If we're talking about the molar mass, we know it's 1. All right, let me not use a highlighter. 1.008. All right, grams equals 1 mole of hydrogen. All right, so what we could say here is that the molar mass of hydrogen is 1.008 grams per mole. All right, so this is the molar mass of hydrogen. You could look at the periodic table and you could actually easily and kind of figure out what is the molar mass of these individual elements. All right, if we're talking about copper here and I ask you what is the molar mass of copper, you basically write this number and we'll say that the molar mass of copper is 63.546 grams per 1 mole. All right, so that's the molar mass of copper. If I ask you what is the molar mass of silver, here it is. All right, the molar mass of silver in this case is 107.868 grams per mole. All right, and so this is the way how you could figure out the molar mass of atoms. Now, You could also figure out the molar mass of compounds. All right, much like how we calculated the molecular weight or the formula weight in the beginning of this video, molar mass of compounds is the same exact way. All right, and so like for example, let's say that we wanted to figure out what is the molar mass. So let's figure out what's the molar mass of glucose. All right, glucose is a sugar. All right, so this is the chemical formula of glucose. All right, and so we have carbon, right? We know the atomic mass, or we know the molar mass of carbon. So the molar mass of carbon is 12.011 grams per mole. And if you notice, there's 6 of them, so I'm going to multiply this number by 6. Okay. Hydrogen, all right, we know that the molar mass is 1.008 grams per mole, and there's 12 of them, so I'm going to multiply this by 12. And then we have oxygen, which the molar mass is 15.999 grams per mole, and we see that we have 6 of them. Okay, so let's go ahead and multiply each of these individual numbers, and so that way we can figure out the molar mass of the overall compound. So when you take 12.011 grams per mole times 6, we have that the total mass of carbon is 72.066 grams per mole. All right, for hydrogen, all right, so it's 1.008 times 12, and we see that the total mass of this is 12.096 grams per mole. And lastly, for oxygen, when we multiply that number by 6, we get 95.994 grams per mole. All right, now what we're going to do, we're going to take the sum of these three, all right, and to figure out what is the molar mass of our compound. And so when we do that and we add them up, we get that the sum of the compound is, the molar mass is 180.156 grams per mole. So this is the molar mass of glucose. All right, and so in this video we looked at atomic weight, molecular weight or formula weight, and how that relates to moles. Okay, and then for moles we understand that molar mass is basically the mass of 1 mole of a particular substance, and then we know how to calculate the moles of atoms and the moles of compounds. All right.